Good. So last class we started some, you can say, basic Java program. So I think say a list of we have a couple of number, maybe 1, 2, 3, any number, and just write the list of numbers. Okay, and we are discussing like this is our source of data, so we can associate the source of data the stream. So how to associate whatever your collections, and we have a stream methods that's provided by the list interface, and after that you will receive the streams, and this stream interface I have given a lots of utility function which generally serve our stream API function, right? So you can say this list interface is not provided like a flat or map or filter. These are the your source of data, and source of data given, hey, these are source of data you can associate with any pipeline, any filter. So how those association happen using this stream method, right?
Yes.
So it's clear. This is your source of data. This is the collections. Okay, and this data you want. Hey, this is, I'm going to create one pipeline. In this pipeline, this should be the source, right? How to associate source? This the method given by this collection interface. So whenever say dot stream means your source of data now associated with a stream, and now here stream you can define any set of pipeline function, right? So started say last class say, hey, we have a couple of methods like maybe a map or maybe filter or maybe anything, right?
Yes.
So last here we are stopped. So notice this map is the kind of a method that are expecting some kind of a function. They are not expecting you can pass integer or float or double. Here look like I'm processing the integer number. So I cannot pass any integer number like a 5 or 6 or 7 or 8. So we have to somehow pass the what the method expects. So in Java basic rule, whenever you are going to call any method, you must aware what are the input types these methods are expecting and what kind of value they are returning. So either method signature, right? For example, this is the main method. So main method says this method take input as a string argument, array of string, and return nothing, right? Similarly, if I am going to call map function, the map method, we should know what the input they are expecting. They are expecting integer, float, string, or what. Until we not know, we cannot call them. Good. So here, things they are expecting. Let's look the library. Library say I am expecting one function. Let's check what is the function. If you check function carefully, function is the interface. That means this map interface are expecting this interface. Interface means just a contract. There could be some implementation class you need. If you want to call this apply function, you have a need the implementation class object, right? Here functional interface, and this is the apply method. But to call them, we need some implementation class. But interface, this is the just syntax. They are not providing actual business logic. So question here, if I want to call here, so functional interface like this is the my functional interface. And this functional interface here have a generic. This generic means this is the one functional interface. This two meaning T and R. T and R just symbolic indication that say, hey, might be T is the any kind of value and R is the any kind of value. This generally both are not the same. If maybe this is the integer, then it can be float. Maybe integer, maybe one value, maybe different value, or maybe same value. T and R just yes.
So could you read what is written the above text above functional interface? Could you scroll a little bit up?
Yes.
Yeah, this lines like represent a function that accepts one argument and produce a result. This is a functional interface whose functional method is apply object. Yeah. So for for the map where we have started and just just uh, just like for my understanding, I just wanted like these lines should to be clear to me. So it's a request like whenever we're coming to this documentation, please explain these lines. Like this was a simple one. I easily
but-
understood this.
So let's try to understand. I'm trying to say first, let's
Yes.
see what is the function.
Yes.
So I'm explaining here why this function map function take function interface.
Mhm.
So
Yes.
one is the basic concept. Your map is a method. Okay, map is a method. They are expecting interface. Simple. So
Yeah.
whenever any methods are expecting interface and you want to call them, so surely we have to pass the object of the interface implementation class. It's the interface with the implementation class. Let this the implementation class. You create the object and pass, right? So similar
Yes.
things we are going to do. First, understand what this function interface, what the method they define. So notice they have a one method like apply. Means what this method syntax? I am receiving one input parameter. What is the input parameter? Here not set integer, float, double. Here set t. T means any types of object. Maybe
Anytime.
integer, maybe float, maybe double, maybe string, maybe employee class, maybe any kind of object.
Mhm.
Right?
Yes.
This interface is so generic, means they are not bound to any specific type. They say return R. Means here say it might be you can whenever you're going to write the business logic of this method, you can return any different type. Maybe integer, maybe float, maybe employee, maybe math, maybe department, any kind of object you return. So this is simple rule. Say, hey, these functions are look like you can give me one input and I can return one out. Means they take one types of input and can returns another types. Maybe same type or another type. If they are same type, then maybe mention the t itself. But here say R. R means return value. T means input type. So this means here T means T indicate first parameter indicate this method will take T types of input. Once they doing the business logic, after that they return R types of value. So this is return value. What kind of value they are going to return, right? So here
Yes.
two indications. So here function at the rate T comma R. Here nothing meaning, but this T and R can be used inside a particular method, right?
Yes.
So let's go. So that means map is a method that take one number or one object and return another object. This simple look. Simple rule. Map is just like a generally map used for the transformation or changing our input from one form to another form. Let's say I want to pass one single number, I want to double it. Maybe I pass one integer, I want to return float. I want to pass one number, maybe I want to return the cube of that number, right? So
Yeah.
one input and one output means one to many kind of relations. Always take one input and always return one value, right? They are not returning the these methods are not expecting any arrays value or multiple value. One value input, one value output, right? So here say, okay, so let's see how I can call this functionality. So if this is the, let's see, if this function are expecting functional interface like a function, okay? So if this is the interface, surely let's I want to create the function object, okay? Object. So surely I cannot create the interface like a new. Okay? Because this is the interface, so we cannot look like this. But
Yes, sir.
interface are not allowed to create the object. Why? If compiler allow, then what happens? You are going to call the apply function, right? And you pass some number. So question is that from this two line, compiler not able to understand in the apply method what I am going to do. I have received 5, but what is the business logic? nowhere business logic defined. Did they say, compiler say, hey, whenever you have an interface, you cannot create the object because this interface have defined some function that are abstract, that are not really implemented. What is the business logic? Not available. So this is not allowed. So,
Yes.
so if it's not allowed, then what kind of object I pass? You can say, hey, go implement some class and override this method so that I can call. So yes, okay, don't worry. I'm going to create class, let's see my function, okay? My function, and I implement this interface. Okay, this interface. This interface, let's get receive integer and output as an integer. So whenever you are going to implement any interface, whatever the abstract method defined here, you have to override them. So let's
Yeah.
they have a multiple method. I'm going to define the apply.
Apply.
So in this way, I'm going to write my function object, and this is my function. Now here I can write this. Okay. Now
Yes.
this is the happy. Say, hey, I have implement this. Not understood. And here this. So in this way, generally you are able to provide the apply method. Now this apply method we can call anywhere, right?
Yes.
So okay. Here, so notice they asking some kind of a type. This is the parameterized types. So someone has say, hey, this should be look like the integer symbol, right?
Generic. Yes. Yes.
Generic and their expression. Okay. So
But it needs
so-
two parameters.
yeah. So yes, integer comma. Okay. In this way we can define, right?
Yes.
So here notice now I have my function object. Okay.
Yes. Yes.
Function object. So now I can surely here pass.
But sir, like
Right.
if we are not using that apply method, then how it is triggering?
Let's listen.
Yes.
So till now, notice till now what we did. We did at least as a basic rule, we have a one interface. I can implement it and give the logic. Let's say I give the logic simply any number, whatever the number we receive. Let's whatever number just multiply by. Let's multiply by 2. Okay, simple, right? So this is my business. We have a apply method. Whatever the number, I'm just multiply by 2 and return the same. So at least I can provide the definition of this. Now let's just now I have this function, and here just recommend it. Here say hey dot apply, okay, and here I pass 5. Okay, so at least just here say this method is no cannot, right? Just okay, call apply. Okay. So now at least this is the till now this is basic rule. One we have a one interface, and this is the implementation class, and I can call this interface. Till now there is no any confusion, right? So
Yes.
at least we know any interface. This is the basic rule. This is the way we can provide the implementation class and do it. Notice apply method call for input 5. It's okay. And if you want to return a value, they return the result, right? Return. Return. Okay, so here you can get the output. So up now I am going to this object I have, and this object I can use any place. Now this is like 5 input and taking the double of those. So as of now we have a this string and dot. So next let's question if I pass the same object here, then what happens, right?
Yes.
So just as of now I comment out, okay, and so they return something, right? Whenever I call, still they return. So notice this map is a method that what return? They return the stream of R. This means whatever this super what do you mean? Just here understand extend means the extend and super to extend. Maybe we can talk more generic than understand. But I just now just try to understand whatever the here we number passing, whatever the here number passing like here. Okay,
Mhm.
this is the kind of subclass we can also pass. Okay, so I just now understand whenever I call map method always return the string of whatever you pass here the integer then return, right? That means in a pipeline, this is a pipeline. In pipeline, source of data is the integer. You can pass here, the only integer can flow from here to here, right? So, and they integer number flow under the box of your stream. The stream is a kind of your pipeline. Here you are traversing your output. Okay. So whatever the map method returns are going to the next function. Directly value cannot transfer, but the under wrapper of your stream. Due to that, always all the intermediate methods of a stream interface are return the stream itself. Right? So now we have seen this is the map stream. Okay. So now we have a just like a source of data and just generate by stream, and from this interest stream I apply the map means transformation with the my transformation object, and after that let's if you want to again notice all these functions are defined under the stream. So all these functions you can again ready for call like filter, like map, right? These are the map to lots of functions we have, map to long. So all these methods are available for your again this object. So maybe I want to just call the forEach. Maybe I can forEach. Okay. So notice forEach is also kind of a method. Notice this what they are into. They are expecting any number or what? They are, let's again check. They are not expecting any number.
Consumer.
So
Will
again
take
they are
input.
expecting some kind of a again interface.
Yeah, will take
That
input
means
now.
yes, you are right. So here this is a notice take one input but not return anything. So this is kind of one function you pass one input but they are not returning anything to you. This return type is the void. Means
Void.
this forEach can take one input but not return any value. Just maybe here inside, maybe write to the file, write to the collection, maybe print, do something inside only. But after that, you cannot get any kind of stream. So notice here, I can got forEach, and similarly, like this functional interface, similarly, we can implement my class, my consumer. Okay, implement consumer interface. Consumer of integer, right?
Yes.
And here I have to overwrite my method. This is the accept method. And notice accept not returning anything. Here maybe I can say simply this is the call, right? Accept method call for integer and just you cannot do anything. Just because they return void that you can print here or something, right? But this is the input we call. So now this object we can surely I pass here. Direct you can pass a create object, right?
Yes.
So what are you doing? Okay, hey stream, you are expecting one consumer. This is the interface. Then I already have my implementation class. Just this implementation class. What they are expecting? They are expecting one input and just printing them, right?
Yes.
So here, so what we did? So couple of things we did here. So let's cut out here. Okay. So here you can say rename source data. Source. Okay. Source data. This is my source of data. From source data, we can associate with a stream. From a stream, we have applied some kind of transformation We have a transformation. In this transformation, I can apply forEach, and what they can again is return something. So notice they cannot return anything. Notice because this forEach function is the
Right.
means this is the terminal operation. Notice here, this is the terminal operation. Terminal means they can take input, but after that, they are maybe returning any primitive value or maybe void. Some terminal function can return exact number, not the string, right? So here notice map. Map return the string. Means this is the intermediate operation. Notice here, this is the intermediate operation because they are again inside a pipeline. Okay. From here, we cannot go to outside of pipeline. Still, you are inside a pipeline. So here, source data associated with the pipeline. For pipeline with transformation, and transformation after that, you can suggest and just close it. So till now, if you run from source data, one data I pass to my source data to string, and each strings are going to the map them, and after map, I'm going to just consume them. So in this way, notice here, first apply for 1, then accept multiple of 2, and then apply for 2 and multiple of 4, right? Again, for each number, notice we are going to the call pipeline, right?
Yes.
So in this way, whatever the implementation you can give in work file. But generally, already we know any interface is not really needed to writing this kind of big class, right? Big class. We can already know how to concise it. With the help of lambda expression, even these things written in a more smart and simplest, right?
So like I have one question here.
Yes.
Like inside map, could you click on this my function object?
This is the my function object.
No, above, in the stream method, in the stream vanilla.
Yes, in this.
Yeah. My that object.
Here.
No. Could you go back to that streamline?
Yeah.
My function object.
My function object. This one.
Yes.
Yes.
Yeah, it pointed here, and it's so how it pointed to that apply method. So it will run that apply automatically.
No.
So
what the
yes.
Yeah, let's understand what is the logic given. Map functions are implemented by which interface? This interface.
Yes.
See, if you try to implement this, notice here there are lots of implements. Let's figure out these are the implementers, right? And
Yes.
whenever you can call, notice here map have a function. They know on this object I have to call the accept map.
Okay.
So why? Because this map stream I already know this functional interface have only one method apply. So I can just if you give me the object, I can internally call your method accept because apply because I know this map have only one apply method. So this map function similar behavior. Let's write for you. You also write them. So instead of this map, you write your own map, right? I write static void kind of my map, okay? My map function, okay? And in my map function, let's take a functional interface, right? Yes. Functional interface, okay? And here let's say integer comma. And I know whenever I map function so I know I have to call apply. Yes. Because this is the interface I can apply. So notice question, what the value here we pass?
Obviously.
Here, maybe I have to pass some 8 or 5 hard-coded value, right? So notice here, I'm not sending any value. Notice source data, this is the example 1. Here, this data comes somehow here. You are just giving the function. What is the value? This value is passed by the stream itself. Let's understand. Whenever you have a source of data, like 1, 2, 3, right? Whenever you say stream, you can open one pipeline, right? It's the pipeline. Here, I'm just associated this my stream with pipeline. Here say map. Here is the one function map. This data, like 2, they are going to the pass here. Okay, but notice you are passing the object only. You are not passing any value. But this map function say, okay, let me, I receive this 2 value, but I have to call on which apply method of map, and apply method need a one input. So notice here, apply method need a one input. So whatever the association, this is a link source to stream. This source data as a simple for each loop, they are going to the calling your function, right? So this map is no, this is the my functional interface object, and whatever the input this source give me as a number, I am going to pass in the apply method. So this implementation is given by your library. Library say, just you give me what is the definition of apply. What is the definition of apply? I can call your function, but calling is under the stream. You are not calling the apply method. Even last class, you notice, even this method name is not so important. Why? Because this method, we only interested with input and output value.
Yes.
So due to that, this is the way here you writing code, so you are not understanding how apply method call. Apply method in the functional interface, just you can say developer hint what kind of input and what kind of output. This name maybe doesn't any make sense. Even any method which have input, one input and one output, I can call, even non-apply method as well. The function name here is in the functional interface just negligible meanings. We'll talk later why negligible. So first understand, whenever you are source give data, this data pass to this function, and this function have a apply method, and that take one input argument. Those input argument are supplied by this map. So notice here, this map function, you are just using the this interface, right?
Yes.
I am not providing the implementation of this interface. I am not providing the implementation of map method. Notice this
Yes.
implementation is provided by your library, right? Only what I providing you want to one functional object. I am giving the one definition. Whatever the you receive number, you call my apply method. So internally from this map method, this library know this is the functional interface. They have a one apply method. I can call your method. So here, JDK library map function calls the my definition what I am given to the apply method, right?
Yes.
So somehow here no, you are thinking look like some magic. No, nothing magic. All the implementation of this method is not providing you. This is the
Yes.
just we are using the library function, right?
Exactly. And so, like when the Steam started, I have a container that is associated with the Steam and having the value 1, 2, 3, 4. So will that, like when it reaches to source data is containing all the data at that moment. Let's
No.
go source. Okay, source
So-
data will take first element.
Source one by one. This is the source like 2, 3, and this is the 3 element, right? And you are
Yes.
just associated one pipeline, okay? Till now.
So
At a
happened?
time,
Yes,
ask a
what
question.
happened when? Yeah, what happened? Now source data is carrying these three values, 2, 3, 4, right?
No, not 3 value, just one by one value. At a time,
Okay.
till now, this line only make association. This pipeline just link to the here. At a time, all 3 value not go to the pipeline. First thing.
Okay.
Only value, first value 2 pass to this pipeline first function. What is the my function? Map.
Yeah.
So map, we have pass map function. Notice one object you pass as a developer. One number input number 2 is passed by our library. This map function is internally receive two objects. One you pass the implementation class, another your input number 2. Okay, so now our map library know this is my object, and this is my input number. I have to call this input number to the apply. So this is implicitly passed in this map method. So, and if you have a one map function, another, let's say you have another, like here in our case forEach. So again, this number passed to the next function. So whatever your apply function return, again go to the input for your forEach. So until you are not reach the forEach. Notice here, once you reach, after that they return void. forEach not return anything. So here our library hold is the printing. Whatever the data here, in our case, I write the system.out printer. Here it stops. Now again, internally, library send the new number. This.
Okay.
So again we receive one. Again call the map function, your implementation object, or three number input number 3. Then apply return value, again call to the map function. And whatever the output of this, just hold temporary here, right? Again, go to the next, pass here next. Again, go to the map function call. What the output? Go to the forEach. Again, once this source completed, that after that you are getting all complete data here and output. So at a time in a pipeline, only one source data transfer.
Sir, could you repeat last line?
I'm saying whenever your pipeline, this is the source of data, one data go here till that this, and
This for
the
each
terminal operation they hold. Whatever the calculator result, they are hold temporarily here for it. They are not just printing on the screen as of now. They are going to the process next element. Do after holding the next data here. Again processing the third. They are holding the data. Finally, all the source completed. Then this pipeline say, hey, pipeline done. This is the one thing. One pipeline is open, and once reach the terminal operation and all the input is done, after that this pipeline is the permanently closed. Now we cannot reuse this pipe. That means, so now this here pipeline is closed. Again, if you try to same thing, right? Logically, I can again say, hey, stream dot let's filter, right? My opinion, right? Yeah, find it. Here you cannot do, because this stream is started here, go here, after that come here, and after that here stream is closed. So whenever from this stream, you cannot again do any kind of things, right? Even you cannot do same operation like here, you cannot do again. Here you cannot do again, because your finally stream is closed.
Yes.
So this is the one disadvantage I realize in the stream API. Many other languages are not closing stream. You can use any number of time, right? Because your source of data is immutable. Our stream API is not mutating anything. But the Java designer say, hey, let's in our pipelines, one data processing done till reach the terminal operation. After that, the stream is closed. So due to this reason, generally we are not writing code this. Because if you're writing this way code, someone can going to use this object again, right?
Yes.
And in this time, you run application runtime through exception. Hey, your pipeline is already closed. We cannot reuse this pipeline. Notice here, stream have already operated, right? Are closed. So this is the intentionally designed by the Java designer. Due to this nature, generally we are not using this line. So we can say generally we are avoiding this. And we can say, hey, I know this is the, notice here, this is the same object you are using here.
Yes.
Why you are declaring unavailable? You can say this is already using, so just you can remove everything. And even
Yes.
this is the same thing, even you can say remove everything here.
Yes, yes.
Okay. Even there is a no need of this because we cannot reuse again. So you can say don't use them. You can simple say this. Okay, and you cannot use them, you cannot use this. Generally prefer we write code in this way because I know stream is only one time open, process the pipeline and close it. But there is no make sense you can create the variable and use the memory, right? So generally we write code this. Hey, source data, associate stream, start the pipeline, pipeline 1, pipeline 2, and just close.
Okay.
Right?
So I have two questions, sir.
Yes.
So my terminal operators are immutable, right?
No.
They are immutable or mutable? And
This is
what about
this is not mutable, and even this is not a because notice mutable and immutable require the object, right?
yes?
These are the function. Function don't have no. This function don't have a state. This function don't have any storage location,
But
right?
they have the reference value also.
Reference value, but this my consumer instance is the one object. They don't have any just what simple thing. They have a one function. Just you passing something and I'm returning. Are you passing something? I'm just printing. So on the data which are giving me, your data is a source of data. Source of data can be collection can be mutable or immutable. But all the function like map or filter or forEach, these are the function. So function generally don't have a state. There is no any concept of mutating anything because they are not holding any value. Map function, they are not holding any value. forEach function not holding any value. They are just processing. For between little times, they receiving your input, do something and again return back. They receiving something, do something and print on the console. They are not holding any value. So here there is no any question the map or filter or terminal operations are mutable or immutable because they are not holding any value. What the operation inside you are doing? You can change the value something. That's another matter. But technically, these functions are not the object. And always mutable, yeah, immutable terms come under the object. Until you have not any object, an object have some state and value. Then someone going to the change or just someone going to the cannot change. There are two options. So always things here source of data. This can be mutable or can be immutable because they are holding the data. But these the function like map, they are not holding your data. Just they are bypassing. Function is a bypass. You pass something, I am doing processing something, and I return the new value to you. Even the pipeline say, whatever the source of data, I never modified your source of data. Whatever you are doing here, and whatever the operation going double, something, always happen the new copy. This original copy as intent without any touch. We are not doing any modification. Even those here we are modifying. Let's say I print here first is out. Is out, and here also again my print. This is my source of data, and after that also I reach the source of. Notice here I already read each and every value. Let's just for simple number two, right? Okay. Here I receive some number and do some do multiplication of double up to. But notice our source data is no any change. This is the core feature of our pipeline. Pipeline is not going to modify source of data. Okay. Notice here initially 579 and after that also 579. Between that you can change the value double, right? Yes. So notice object which hold value. Let's check those value you are able to modify or not. So notice here, this map function just receive input and just respond. They are not holding any state. Any confusion till now?
No.
Any function, there is a wrong question. You can say this function is the mutable or immutable. Mutable, immutable, always associated to the object. Means we have some object, some state, something our function allowed to mutate or not mutate. A question here, map function can mutate anything? Yes, in the inside the business logic, you maybe mutate any file system or change the object, something, right? Maybe this variable is a global variable. Let's somehow I write the global variable here, right? Here, global variable. Let's say the state, right? And now this is the static variable. Maybe somehow this variable somehow I can pass here, and in the map function I can modify it somehow. So if you are intentionally want to modify, you can do. But logically, if you are going to the as per the guidelines of the Stream API, generally say inside the any function, don't change any input. Such function known as you might be know any function take input, okay, and do some processing and just return output. There is no change on input. Even this function is not going to the modify any database or any file system. Such function known as a pure function. What is the pure function? Pure function is a function that just take input, do some processing and returns value. This function is not responsible to going to change any global variable, any global object, and any file system. Those functions you cannot say the pure function. So as per the guidelines of Stream API, all the function map, filter, or any match, all should be your pure function. Pure function is just depend on the your input and return output. And one thing note, same input always return the same output. This is the one also quality of pure function. If any function you pass a number of input, if and they return the B output, if you call this function 100 times, always return the P. That time say this is the pure function. And all
Yes.
the Stream API function logically, as per the guidelines, must be pure function. Always prefer to write a function that cannot change any other global variable or any shared object or any file system or something. If our business required, sometime required the mutable. I'm not say immutable is a good thing and immutable is the bad thing. Both are the good thing. Both have a different use case. Sometimes
Yes.
really required our mutation. Without mutation, we cannot live, right? Sometimes not required. So stream is the area generally prefer immutability. Means don't change any source of data.
Okay. Yeah. One more question, sir.
Yes.
Let's suppose I have a value int a is equal to 10.
A just variable and value is a 10, right?
Can I use this inside a string?
Why not?
How? So
Everything you can do. Okay. Don't worry.
a
We'll
dot
talk.
string. Okay. Okay.
Okay. I got your question. So you say, now I understand. You say integer a equal to 10, right?
Yes.
And you are trying to say here I can start the stream or not, right?
Yes. Yes.
So first thing, notice to associate. This is the source of data. Surely we have one data 10, right? One data 10. But
Yes.
this is 10 are the primitive value.
Primitive. Yeah.
Primitive value means this is the just value and they don't have any function. In the a dot, because this is the not object. So you know what is the meaning of object and what is the meaning of primitive. So here I am saying this is the primitive value.
Primitive value.
I am saying it is a not an object. So what is the meaning?
So we need to use any kind of a wrapper classes, and based upon that, there is a possibility we can like auto boxing and unboxing.
Yeah. So here the object is that whenever any method you call, because if you want to start your stream API, you need to call this stream method, right?
Yes.
This stream method is called, we need a one object, right? Without object, you cannot call the stream, right? So
Yes.
here, I don't have any object, right? I don't have any object, so I cannot call the stream. So technically, if you talk region, pipe, no, notice stream is designed to process some set of operation on given one input, right?
Yes.
So here we have a one input variable, but there is no any object, so I cannot start a stream. But sometime I want, right? I want this 10 value go to the pipeline. So Java designer say, hey, you have an alternative. If really want, so I give you the alternative. How you can start a stream? So let's say, hey, I can stream stream have a some static method. Here say off, and you
Off.
pass this value a.
Okay.
Now your a part of the stream source. Now here you can do any kind of operation like a forEach, map, division, everything you can.
Okay.
Right? So here you can say map, you can say map, whatever the map function I can pass here map, and here say, hey, I want to print, or is I want to print. This is my consumer, I can print. So this way, not directly, but indirectly, you are able to pass your primitive value in the pipeline. But you have to just different. Notice here I pass the 5 and 10 and become a 20, right?
Mhm.
So this is known as a stream generator function or stream factory function. So stream class is provided some kind of a function from where you can start the stream. Notice here I'm not called dot stream. Why? This is already written stream. Off method is return the stream. Notice stream.
Yes.
So somehow you can start, maybe here our source of data may be list. Here my source of data may be primitive value, right? But we have to go with the stream generator. So whenever we have a one value, one variable, one object, yeah, two object, yeah, 10 object. Maybe you have a two variable, right? A comma B, right? A comma B. You can associate this in the pipeline. You can say A comma B here, right?
Okay.
Now it's become a two variable part of this my stream.
So we can give any kind of value inside this off, right?
Here you can let's key string, employee, any kind of object, because this is the just generator class. Here say F say, hey, I can generate stream implementation for you. So notice here, our collections have a method stream. They provide the implementation of your map method and forEach method. Similarly, if these are the primitive value, they cannot provide the implementation of your map method or forEach method. But somehow stream API say, don't worry, I am going to provide you this implementation for you. So just use my generator function. So there are lots of generator function, stream of, stream iterate, and multiple things, right? You can explore lots of function. Even you can say, hey, stream, you can say off or builder. You can also use the builder to start the building, and maybe you can just say empty, or you can just say generate, or you can say iterate. Iterate look like a forEach. Let's say I want to similarly like the range function of integer, right? So here say, hey, I want to 10 number, okay, 20 number. So surely these things you can explore. Any doubt I'll talk. But all these API like iterate, generate, empty, builder, of, multiple of, they are provide you to start streaming on any specific value. Any doubt? Any question?
Mm, yes. Like I tried iterate method in the past, but I wasn't able to perform.
Let's
Yes.
okay. Let's go. Let's iterate. Okay. So let's understand the syntax. So iterate function have a two overloaded math. Notice one
Yes.
is the one seed value, starting value. This is the one
Unary operator.
unary operator. Unary operator, no.
No.
There are two kind of one is a binary operator, one is the unary operator. Binary
Yeah,
operator like binary
It
operator
is-
like plus, minus, division, right? Unary operator like negate, plus, plus, minus, minus, increment,
Okay,
decrement,
okay.
right?
Okay.
Right? So here say, let's I start with the 10. This is the initial value. Seed means initial value. And what would be our next number? So what's the key? Whatever the next number my, just say number, question how many times you want, because this is the iterate means look like a loop, and whenever you're writing a loop you have the initial value and condition till how many time our loop go, right? Okay, so here say maybe and
Plus one.
less than maybe 20. Okay, and third parameter we're going to say, hey, we are going to increment or decrement. Okay, whatever the maybe number, I say number plus. Okay.
Okay.
Okay, and here after that, what you want to say? They want to for it, just print value, right?
Yes.
So this is the way.
best. I think this is the best to use the things.
So what say?
And plus plus.
Okay, say n equal to
And
n plus 1. Not an issue. Okay. And if you run here the semicolon, you can generate. Notice here I've generated ton stream number. Here you can do for each map, everything, whatever you want, right? Map, whatever number, number plus maybe 1, whatever, right? All the operation you can do till less than number.
yes.
So these are the, you can say, many sometime in our application we are going to use this. So we'll talk.
Yes.
We'll talk more about this. But these are the syntax semantic. Okay.
Yeah, today it was very helpful session. I learned of basics.
So here, just go to the wrap of the day. So notice this is the one way we are writing code right now. But generally, in Stream API, we are not more interested to write like this, right? My exception, my
We use lambdas.
yeah. So already we know how we can use the implementation class or maybe anonymous function. Here you can pass anonymous function as well as, or here you can pass the lambda expression, or here you can pass the method reference. So this map functions are for each function. Java give us the 4 different way to use. Maybe implementation class, maybe anonymous class, maybe lambda expression, maybe method reference. All are feasible. Even here, I can pass any method reference. Let's say this is my map, and here simply say this will take one input and return, just instead of void here say return integer, and here say whatever the number and return number plus number. I don't know, right? So even this function is look like here you can say my map function I can call here. Even this I can say hey dot map. I can say hey this is my sample class and map. It is working because this is map function. There is no method like apply, but they are calling n plus 1. because the syntax is input one and return out. So even map function, you can use the method reference, or even you can say, hey, I don't have any method. You can say, hey, map. You can say, I want to anonymous method. You can say new functional interface and just override the value here.
But so like in the line number 20, why it haven't picked any kind of function with it?
I'll just talk.
Okay.
Just say here, just say override. And here say whatever the number, okay, integer plus integer. Okay, so even out the lambda function, it's work the same behavior as previously worked, right? Even
Yes.
so nowadays, even this way, or even say simply nowadays, say, hey, why not I write this code itself here, input n and plus 1. Directly I can write the code here itself, using the input and lambda expression and our business logic, right?
Yeah, this is like understandable, like it's function method. But
So
here in
here,
line number 20, yeah.
yeah, here. So if notice what this function say, this map interface say I need the one functional interface that have a one input that take one type and return one value. If any function that follow this signature, this is the implementation of a map interface. So notice this the my map function. What the my map function? Take one input and return one value, right? So it is the properly notice. This is the core business logic. This business logic same as your lambda expression. Notice this is the same thing. N input n plus 1. You can write code here or you can code write here or anywhere.
Okay.
So
in line
there,
number in line number 43, if this method is not static, then
and you can object level, you can make the object of this class and call them. Okay. You can just make the object of this class and call them. Okay. Generally in the main method, so I'm making static. Okay. This is not always sometimes static and non-static. Both can use the method reference, right? You need the object of that, right?
yes.
So here intention is that finally you have to write one method that takes some input and some return out. This code, input and output, even you can write in a separate method or in a separate class or itself inside your code or directly in the lambda expression. So generally nowadays more preferable, why I am writing other things, preferable this way or this way. Even this is the more readable than this. This is the more readable, more meaningful than this. Here I can say simple that maybe double it, right? This function I can double it, okay? Double it, right? And here makes sense. I am going to map means double it, right? So instead of this code or this code, this is the more readable because in your hand, you know how I'm giving the meaning. Someone understand, hey, map double it, right? So this is very convenient, right? Very readable. Is it clear?
Yes.
So
So like
you can pass any method name here which follow the syntax this input and out. If here is a void, then you cannot pass, right?
yes.
Yes, ask question. Sorry.
Yeah, at line number 43, let's now I just remove the static. Then I need to create the object of this class. Based
Again,
upon
then
that
you can.
object, I need to call that
Method references.
method. Okay, yeah, clear.
Okay, so functional, due to the functional interface, lots of flexibility we have. So let's do practice of this and I will
Yes.
continue. Okay.
Yes.
Initially, it will take time, but these are the things we have to learn, right?
Yeah, these are very, today the session is very crucial for me.
Okay, so now no any question for the day? It's okay.
No question. Yes, thanks.
Okay, take care. Good night. Thank you.